you've not done so. Yes, so I believe so. If anyone wants to talk, you can just wave your hands. Once you wave your hands, I call you, then you can talk. So let me share my screen now. So I'll be sharing my screen now so that we all can see what is to be done. So I'll be sharing my screen now. Yeah. So let's get started. Let's get started. I believe my screen is being shared now. So now to the first thing. Let's move. So we'll be treating nuclear chemistry. We'll be treating nuclear chemistry. So now one thing I want you to note is that anytime you are having a class, get a note. You aren't wasting time. You are preparing for a very high score, and you must be intentional about your approach. Just be intentional. So take notes. I will be very fast so that we can cover fast, and I will be giving some things. Maybe you've not heard it before, or you've heard it before, and you need to take it down. Just make sure you are putting down some things. So let's just get started. Nuclear chemistry. Nuclear chemistry. So the class is being recorded, but just put things down. Okay, so let me start by talking about briefly about what is nuclear chemistry? What is nuclear chemistry about? Now, if you remember, there was this man in 1808 by the name John Dalton. So John Dalton was known as the father of atom. Yes, although atom starts from the Greek where they call it atomos, and I believe you know what atomos means. Atomos means indivisible. So this Greek, they were saying atoms cannot be divided. Then all those Greek philosophers, then so they were the one that started work on atoms. But it came to a time in 1808 when this man came. This man called John Dalton. Okay, I'm sorry. So we have John Dalton. Let me talk about him. So I'm just trying to have a background of what the class is to be, what nuclear chemistry is all about. So when Jordan came in 1808, he talks about atoms. He said he postulated some atomic theory. I know most of us must have heard about that. Most of us must have heard about that. So I'll just run through. Oh, please, let's just mute our mics so that we can be able to hear very well. Let's just mute our mics. Please, I'm sorry if I mute you just so that everyone can be able to hear very well. Yeah. So let's just move on. So John Dalton postulated five theories. John Dalton postulated five theories. What's the first one? He said atoms are made up of indivisible particles. That means atoms can neither be created, they cannot be destroyed. No, that means no. What he meant was that atoms they are made up of indivisible particles. So that means they are the smallest particle of an atom. That means we can't divide them. We can't divide them into subatomic particles. But later we discovered that John Dalton is wrong, although that's not for today. So through the discovery of proton, neutron, and electron. Yeah. So we move on. Then the second theory states that atoms can neither be created nor destroyed, but it can be changed from one form to another. He said we can't destroy atoms, we can't create atoms. So this is where radioactivity comes in. He said maybe we have an atom like this. Maybe we have an atom like this. I think a message was sent to the group. If you have any question, you can only send it to the group. Okay. Oh, for those of you that are not able to connect, please, I'm coming. Let me just attend to them. I'm sorry. Um, or maybe someone can help us attend to them so that we don't waste time. Okay. Yeah. So what am I saying in essence? We're talking about what Jordan was saying. So Jordan was like, oh, atom can neither be created nor destroyed. Atom is this. We can't create it. We can't destroy atom and all of that. Now, what he said was actually somehow right, at least to him. But it came to a time when Henri Becquerel, Marie Curie, and all of that. Henri Becquerel is known as the father of radioactivity. Yeah, you can put that down. I think it's a past question. Henri Becquerel. Okay. Now, those that started were Marie Curie, Now, let me talk about Marie Curie a bit. Marie Curie, I know most of you should know her. She was the first female to have a Nobel Prize in physics and chemistry at the same time. So it was the first one that started work on radioactivity. So he used radon. That was another past question. It dealt with radon. Dealt with radon. It dealt with radon. Okay, let me check what was being said. What is being okay, that's good. That's good you joined. Okay, so let's move on. So Marie Curie was the one that started work on radioactivity. A radon, he worked on radon. Then I said Enrique Querel is the what is the father. Okay, so when they started bombarding, they discovered that what John Darton said is actually wrong because we can create atoms, we can destroy atoms. So what John Darton said in 18 weeks was actually nullified. Now, maybe you don't know how small an atom is. Maybe you don't know how small an atom is. An experiment was combined. Maybe you have a yam now. We divide this yam into two. We still divide this yam into two. We still divide this yam into two. We are now dividing it until we have something very minute that cannot be what? That cannot be destroyed again, that cannot be cut again. So this is how small an atom is, and an atom is actually smaller than this. If you want to know how an atom really is, you can how will I put it now? Maybe if you consider the ray of sun, maybe you're in a room, then the beam of sun suddenly enters your room. How tiny those particles are, that's how small the atom is. So normally, John Darton expected that, this thing should not be divisible. This thing, we should not be able to divide it. But through the phenomenon of radioactivity, we discovered that it's actually divisible. Okay, yeah. So let me just talk on some things. I want to share a picture before, but I don't think it's here. Let me just move on. Okay, so let's start radioactivity proper. That's just an introduction. And I believe you've noted all those things that I said JAMB can ask some past questions on that and all of that. Okay, so let's just start radioactivity proper now. Now, radioactivity is, or we can call it nuclear chemistry, is the aspect of chemistry that deals with the splitting of the atom. The splitting of what? Of the atom. So that's what radioactivity is. It deals with the splitting of the atom. Now, for us to know if an atom can be splitted, if an atom can undergo radioactivity, there's something we have to check for the stability. So let me quickly talk on the stability of an atom. The stability of an atom. The stability of an atom. Okay, yeah. So what's the stability of an atom? The stability of an atom is the neutron-proton ratio of that atom. Now, don't confuse it. You can see some past questions. They say option A, neutron-proton ratio. Option B, proton-neutron ratio. It is what? Neutron-proton ratio. If you are giving it to each other, maybe you are always saying proton-neutron ratio. You can use this thing to learn it. We have we do have nursery and primary school, so it's always nursery before primary school. So you can use that to code it. It's not proton neutron ratio. It is what? It is not it is neutron proton ratio. Neutron proton ratio. So that's how. Okay, yes. If you want me to I'm very, very sorry. Someone called. Someone called. Let's move on. I'm very, very sorry. Someone called. I'm very sorry. Let's move on. Please, if you can hear me, type yes on the group so that I can know that you are following. If you are following, very good, very good. That's good. Okay, yes, let's move on. Let's move on. So we are talking about neutron proton ratio. So that's what determines what? That's what determines stability. Now let's quickly take some examples. Let's check some examples. Now, if they ask you that, okay, is fluorine, I'm sorry, that's an ad. if is fluorine stable or not? Will fluorine undergo radioactivity or not? So if you see that type of question, what's fluorine? Fluorine is what? Atomic number 9, mass number what? Mass number 19. So what's the
Your
neutron?
screen.
Neutron is what? Oh, please let's mute our mics, please. Let's mute our mics so that we
Share
cannot
your
hear me.
screen. Your
Please,
screen. Share
I
your
will have to
screen.
mute everyone now. Okay, I'm not sharing my
Share your
screen.
screen.
I'm very, very sorry. Thank you, thank you, thank you, thank you. It was because of the code that was shared. I'm very, very sorry. Thank you now. So we cannot mute our mics. Please, there will be room for questions later. There will be room for questions later. Definitely. So I'm coming. I want to so that those that are just okay, yeah. So there will be room for questions later, definitely. So we are talking about neutron proton ratio. So what's the neutron of fluorine? 19 minus 9, right? So that's what? That's 10. What's the proton ratio? What's the proton? I mean, proton is the same thing as the what? As the atomic number. That's what? 9. For those of you that did not know how to go get a proton, note that atomic number and proton number and electron number for a neutral atom, they are the same. Ape. For a neutral atom, atomic number and proton number and electron number, they are what? They are the same. Or you can call it anyhow. It can even be EPA. For those of you that are Yoruba, electron number, proton number, atomic number, they are what? They are the same. Can even be PEA. Proton number, electron number, atomic number for a neutral atom, they are the same. So what are we saying? The stability ratio of fluorine is what? 10:9. So let's check for another one. What's the stability ratio for sodium? Sodium is what? 11:23. So what's the neutron? Neutron is what? 23 minus 11, that's 12. What's the proton? That's what? 11. So what's the neutron proton ratio? That's what? 12:11. Do you understand? Okay, back to radioactivity now. Okay, let me just test us using this. So just go to the group now. You type inside there. So what's the neutron proton ratio of magnesium? What's the neutron proton ratio of magnesium? Remember that magnesium is 12:24. Type your answers on the group now. What's the neutron proton ratio of magnesium? Magnesium. Very good. Yeah, that's good. That's good. Okay, yes. A minute more. Yeah. That's very good. So that's 12:12. That's 12:12. So it is 12/12. Now, back to radioactivity. If they ask you, is magnesium stable or not? Is magnesium stable or not? This is how you will know if the stability ratio, the neutron proton ratio is what? Is similar or is approximately equals to 1. If it's near 1, that means what? That atom is what? Is stable. Is stable. Do you understand? Is stable. So that's how to know if an atom can undergo. And once it's stable, that means it can't undergo radioactivity naturally. But once it's unstable, that means it can easily what? It can easily undergo radioactivity. So for stable atoms cannot normally undergo radioactivity, but unstable atoms can do what? They can undergo radioactivity. And how do you know that something is stable? If the stability ratio is what? Is 1. So please let's note that. Let's note that. Another thing that they can ask. I don't know if I'm too fast. Please, if I'm too fast, tell me on the group. If I'm too fast, but I just want us to cover. If you are too fast, just tell me on the group so that I can slow down my pace. I'm coming. Let me just quickly. Let me lay this so that we can have two boards. Yeah. Okay. So let me hear your responses. Okay, I'm too fast. Thank you. Okay, let me explain the last thing. Yes. Please, if you don't understand anything, just tell me on the group. Tell me that you don't understand what I said last. Anything that you don't understand, just type it on the group. I will always check the group. Then I'll be able to explain again and all of that. Okay, yes. So let's move on. So what are we saying in essence? So if you have okay, so I said I want to explain again. We are talking about stability. I told you how to get the stability ratio already. I want to check if some messages just dropped. Okay, let's move. Okay, from EPA and P. Okay, yes, what am I saying? Now, we are explaining something. we're explaining that if we have sodium, for instance, sodium is what 1123. So what's the neutron? Neutron is what? Neutron is what? 23 minus 11. That's 12. I don't want to be fast. I just want to deliver. I'm sorry. So that's okay, let's move to proton. So how do you get proton? Now, if this thing is neutral and does not carry maybe plus or is not carrying maybe minus or anything, if it is neutral like this, no plus, no minus, nothing. This thing that you are looking at here, this 11, is the same thing as the what? As the electron. It's the same thing as the what? It's the same thing as the proton. And it's also the same thing as the what? I'm sorry, it's the same thing as the what? As the atomic number. So in a neutral atom, the electron, the proton, and atomic number, they are the same. And I said you can also call it P. For a neutral atom, the proton, the electron number, and the atomic number, they are the same. And I said you can also call it A. So for a neutral atom, the atomic number, the proton number, and the electron number are the same. I think I have a message in the group. Okay. Good. Can someone please help me to explain? Oh, I'm sorry. I didn't think. What should I do? Sorry. Maybe I will have to make a video explanation on how to connect immediately after this class. I'm sorry for the delay. Just have to answer everyone. How many people are connected? Okay, 26. Let's move on. So that's just that. Okay, back to radioactivity. So we are talking about stability.
Стал делать вычисления вручную. Обычный
So back to what I'm saying. I said if the stability of if the neutron proton ratio N over P of an element or of an atom is 1, that means that atom is what? Is stable. But if it is not 1 or not, if it's not near 1, that means it is what? It is unstable. If you understand up to this point, maybe you are having 2 or you're having 2.3, it's not stable. Now, what information will this provide you? Now, if something is stable, that means it cannot normally undergo radioactivity. You can only force it. But if it is unstable, it can It can undergo radioactivity. Do you understand? So that's just it. If an element is stable, it cannot normally undergo radioactivity. But it's unstable. It can undergo radioactivity. Take it this way. Maybe you are using the board. Let me leave it. But you should be done now. Yeah, take it this way. If you have two children, this is child 1, this is child 2. This child, he has everything he needs. Everything. Food. For this one, no parents, no food. Nothing. He's struggling. This one is what? This one is stable. And this one is what? This one is what? Unstable. Now, this one that is stable, that have everything that he needs, and he has everything that he needs. This one cannot normally, under normal circumstances, be involved in social vices. It can't be breaking things down. It can't be breaking things down. But this one that is unstable, normally, because there is no means, even if it's breaking things down and all of that, at least we can still understand. Do you understand? So now this is it. This one that cannot normally break things down. What is radioactivity? Breaking things down, splitting. So this one that is very stable, that cannot normally break things down, cannot normally split. So it cannot normally undergo radioactivity. But this one that is unstable, no food. The neutron proton ratio is low. The social amenities that it has access to is low. It can normally do what? It can normally undergo radioactivity. Normally. It can normally split. It can normally break. It can normally vandalize and all of that. So I believe you understand now. Please, if you understand, type yes on the group so that I can move on to the next part. If you understand, type yes on the group. Good. So I don't think there's any question. Yeah. So let's move on. If there's a question, you can just type it on the group. I will check it. I will check it. So let's move on. Let's move on. So let me quickly talk on some things. I just remembered all these things, they are jump questions. I will advise you write. And if you like, you may not, you may not, you may not. Okay, so let me give some examples of some. Okay, now this is an important jump question. If you check your jump pass question, I think it should be 1990, maybe 7 or thereabouts. Yeah. There's this thing that atoms that undergo radioactivity naturally, they start from, I think it's something like that. But let me just give what the answer is. Let me give what the answer is. Bismuth from 83 and above. And the atomic number of bismuth is what? I think it's 209. I think it should be 209. Yeah. So once the element is greater than what? Than bismuth in the periodic table, it will normally what? It will normally undergo radioactivity. So it is unstable. Unstable. And once it is unstable, it will do what? It will undergo radioactivity. So all the elements that are above bismuth, they are what? They are unstable and they can undergo radioactivity. So the atomic number, they can ask using atomic number that it is elements greater than what? Greater than 83 or greater than bismuth. Anyhow, now. Hi. So I want to quickly talk on some things. There are some elements. You know, normally, all those elements between elements 1 and 20, they shouldn't undergo radioactivity because what? They are stable. So you shouldn't normally expect that an element like sodium, an element like fluorine, an element like carbon, an element like potassium can undergo radioactivity. Now, it's just something you can relate to. Children below 20 years old, they should normally have everything they have. We shouldn't expect a 10-year-old child to be in armed robbery because it's somehow stable, at least to a great extent. So what is that telling you? Elements below 20 are normally stable and will not undergo radioactivity spontaneously. So they have, for them to undergo radioactivity, it has to be artificial. So that will lead me to the
Калькулятор
type of.
бесполезен, а приложение не дает.
I felt some people may need to write this. Let me just wait a bit. 30 seconds more. Okay, 20 seconds now. If you're writing, just write. So I said elements below atomic number 20 cannot undergo radioactivity. They shouldn't. They aren't expected. It can only be forced. It isn't spontaneous. So let's move. Very, very sorry. My mother called. Please, if you are still listening to me, type yes. My mother called. That's why you can't say the other time. If you can now listen to me, type yes. Very good. Thanks so much. Yeah. Very good. Let's move on now. So, okay, let me just ask: am I too fast? Did you get everything I've said up to this level? If you've grabbed what I've said up to this level, please just type case again so that I can. But if you don't get, type no. And if you have a question, please ask. Let me give room for questions now. Room for questions. Okay, I'm not sharing my screen yet. Let me do that. Okay, yeah. I'm sharing my screen now. I'm sharing my screen again now. I'm sharing again. Okay, yes, I said bismuth. Bismuth is atomic number 83, mass number 209. Any other question? Yes, bismuth is atomic number 83, mass number 209. Natural radioactivity starts from that. Okay, yes, a question. Please go ahead. Yeah. Okay, yes, I will try to come back. I will repeat what I said now. I'll repeat 12:30. Please ask all your questions now. I'll be taking questions from now to 12:30. I'll be taking questions from now to 12:30 based on everything that we said. Based on everything that we said. Bismuth is what? Bismuth is unstable. From that bismuth till every other thing. Bismuth, radium, polonium, uranium, all of them, they're unstable. But elements below, now, they are unstable, yes, so they are naturally radioactive. They're naturally radioactive. Ask your questions. Is anyone typing? It's almost 12:30. It's almost 12:30. Please, let's be fast. Let's be fast. I have to leave the first topic by 12:30. The class is actually divided into 3, and each session should take 40 minutes. I divided all the topics, all the nuclear chemistry into 3. Then we should, okay. Why do elements undergo radioactivity? Now, they undergo radioactivity because they have the tendency to split. Now, I said that when the class started, that John Darkin actually said that elements cannot. So some elements, they are just too big. They are not stable. So they have to break down. They have to split. Elements above it 3. So that's why they undergo radioactivity. Are there elements that don't partake in radioactive reactions regardless? Yes. There are many elements like that. And natural and artificial, they don't partake in any. I will be talking on that now. So elements below 20, yes, they are stable and they are artificially radioactive. Because normally they should be stable. They are stable. So it's only elements that are unstable that undergo radioactive naturally. So even if elements below 20 are to undergo radioactivity, it will be artificial radioactivity. So this is 12:30. Let me finish up. Then we take a quick quiz. Then we move to the next subtopic. We take a quick quiz and we move to the last subtopic and call it a day under nuclear chemistry. So let's move on. Let me quickly. Oh, is there a question? Okay. No, we are treating nuclear chemistry. Wait, how will you be asking this time? Are you sure you are getting what you are saying like this? And also, you should have read before the class. No, it's wrong. We are chasing 320. You should have read before the class. That's very, very wrong. Please, let's always read. Before the class. Okay, yeah. So I want to talk elements below 20. I said normally they are stable. Then normally, I'm sorry, I'm rushing. I have to finish this topic. So this subtopic by 12:30 normally. So I said they are normally stable. Yes, and once they are normally stable, they are what? They can't undergo radioactivity naturally. They have to undergo it artificially. Yeah. So let's go. If they are to undergo radioactivity artificially, what will happen? Now there are some elements like that. Let me just quickly talk on them. We have carbon. We have hydrogen. Please be taking notes. We have sodium and we have potassium. Out of the 20 elements, these 4 elements, they do what? They undergo artificial radioactivity. They undergo artificial radioactivity. So let me take them one after the other. I will just talk on them. It's not in the textbooks, but I think it's not in chapter 19 of new school chemistry. That's where radioactivity is. I don't think it's there. Yeah, I didn't read it, but I've read it before. But what am I saying? Jam used to ask. So let's just quickly talk on them. Carbon. Let's check the radioactive isotopes of carbon. Normally carbon should be what? 12. But when carbon undergoes artificial radioactivity, we can still get what? 13. Carbon 13. We can even still get what? Carbon 14. Now take note. This carbon 14 is a what? Is a radioactive isotope. And it's used for what? In archaeology. It's used in what? Archaeology. It's used in archaeology. So we use it in archaeology. What's archaeology? Archaeology is what? Carbon dating. Like for instance, there can be a rock. Maybe that rock has been in existence for years. The rock has been in existence for years, and we want to determine the age. So through the principle of carbon dating, we can know the age of that rock. And what's the elements we use? We use carbon 14. And that process, we call it what? Archaeology. Let me quickly talk on this. It's actually biology, evolution, where they talk about paleontology. Now, what's paleontology? Is the study of fossil records. Now, what Charles Darwin was saying in that place that if you want to know the fossil records, if you want to determine the evolutionary trend, we can determine the age of all those fossils, we can determine their age. And what do we use? We use what? Carbon-14. And the process is what? Archaeology. It's archaeology. Let me just stop there. Let me stop there. I'm diverting, but you will need it. They are jam questions. Yeah, next one, hydrogen. Normally hydrogen have 3 isotopes, but one of them is what? Okay, let me just in this place. Hydrogen have 3 isotopes, but one of them is what? Radioactive. We have hydrogen 1, hydrogen 2, and what? Hydrogen 3. This hydrogen 3 is what? Is radioactive. This one is what? Radioactive. It's radioactive. Now, another name for hydrogen 3, we call it what? Tritium. God. I hope you are jotting. We call it tritium. Another name for hydrogen 1, the common one you know, we call it what? Proteome. Don't see a jam question and they did not tell you hydrogen and they tell you proteome and you are wondering, what is this? What is proteome? Proteome is the same thing as what? Hydrogen 1. Why this one that is H2? We call it what? Deuterium. We call it deuterium. I think there's a jam pass question where they ask that deuterium is also called, we call it what? Another name for deuterium is what? Heavy hydrogen. Heavy hydrogen. So don't see all these things and be confused. Now, if they say out of all these 3 isotopes, which one is radioactive? Which one will be radioactive? Hydrogen 3. Hydrogen 3 is radioactive. It's also called tritium. Hydrogen 1 is not radioactive. It occurs naturally. It's also called proteome. Hydrogen 2 is called deuterium. Or we also call it what? Heavy hydrogen. Now. I remember another jam pass question. So where they can say, I remember, good. Now, I think the question that they were asking that particular year is that what's called heavy water? You know, normally when proteome reacts, this H1, when proteome reacts with what? Oxygen, it will give you what? H2O. This is called what? Water, Abby. But when deuterium reacts, when deuterium reacts with what? When it reacts with oxygen, it will give you what? D2O. Instead of H2O, it will be D2O. Now, this D2O, we call it what? Heavy water. And why do we call it heavy water? Another jam pass question. Because it has a what? It has the higher relative molecular mass and higher relative molecular mass. Let's try to find the relative molecular mass of this one. 2 plus 16, that's what? 18. Deuterium is what? 2. 2 plus 16. No, I'm sorry. This one, okay, yeah. So we have deuterium is what? Is 2. Remember that deuterium is the same thing as 2H. So 2 times 2, that's what? 4. 4 plus 16, that's what? 20. So we call it heavy water because the molar mass of D2O is greater than the molar mass of H2O. Don't worry. It's not part of nuclear chemistry. They are just jam pass questions that they can ask. If you get it, that's good, but it's not really compulsory you get it as far as this topic is concerned. It's what? Heavy hydrogen. Yes, thank you. I'm sorry if the network is not really good. I'm sorry. So that has brought us to the end of this subtopic. Please, if you have a question, please ask me now. Let me talk on one more thing. Now, radioactivity is accompanied by the emission of 4 things. It can be what? Alpha particle, beta particle, or what? Or gamma ray. Remember, gamma is not called gamma particle. Only these ones are what? Are particles. Gamma is the what? Is an electromagnetic radiation. Now, the fourth thing that is accompanied with radioactivity is what? We call it energy. We call that type of energy is it ionizing? No, not ionizing energy. Radiation energy. Yeah. So it's accompanied by alpha particle, beta particle, gamma ray, and energy. Yeah. So that's just that about that. Let's take questions now. Then have a quiz. Yeah. Okay. Yeah. Sodium. Sodium. Let me talk on sodium. I think that's the last. Sodium have two. We have normally sodium 23 and what? Sodium 24. So this sodium 24 is what? Is radioactive. Why this sodium 23 is what? Is the normal sodium we all know. Please ask your questions now. Ask your questions now. Ask your question between now and 12:40. H3 is also called tritium. No, elements above 20 are not unstable. Only elements above atomic number 83, bismuth, are unstable. What I'm saying, why I talked on the 20 elements is that normally elements elements between atomic number 1 and 20, they should normally be what? Be naturally radioactive. I'm only giving some cases. I actually wanted to talk on the 4 elements between 1 and 20 that are artificially radioactive. That's why I said that. Okay, if you are ready for the quiz now, just type yes. If you are ready for the quiz on what you just learned on the first subtopic, type yes. So I will be sharing the quiz now. So yeah, sodium 24 is the radioactive. Yeah. Ask your questions. Ask your questions. I will attend to them while the quiz is on. So let me end this video chat now and share it to the group. Yeah, okay. I will end the video chat now. Let me stop the recording first.